Well guys, let's solve this limit, but let's answer the question first. In how many ways did you come up to solve this one limit? Well, I came up with 7 processes. So 7 is not the answer, by the way, for those who just clicked on the thumbnail. Um, yeah, I came up with 7 ways to solve this limit. How many did you guys come up with? Let me know in the comments below. And now I'll start the 7 ways I came up with. First, what I'll do first is here I'll just take square root of x common. So this becomes square root of 3x square minus 1. Now we can just put the limit in, because here originally it was an infinity minus infinity case, which was, well, indeterminate. And now when you put infinity over here, this now becomes infinity by infinity minus 1. Infinity minus 1, infinity, infinity into infinity. So simply this is just infinity, and that is the first way. Now for the rest of the 6 ways, I just had to rationalize it. So that means I'll demonstrate it by using comma. So when we rationalize it, we have to multiply it with its conjugate, which is root 3x cubed plus, let me just show you in the denominator, root 3x cubed plus root x. We have to multiply this on numerator and denominator, and when we do that in the above, it becomes a minus b into a plus b. So that's just a square minus b square. So that means this square, which we remove the root, and that square in which we also remove the root. So now from here I have the 6 remaining of the 6 ways I can do from here. So second, let me just check. Okay, so I'll start out with an long and interesting one. So first, let's see if what happens if we put the limit. So this is infinity minus infinity, and it's also infinity. This is a wild case. But what we can do here, you can see we have infinity minus infinity by infinity. It would be easy if we could separate it, so it becomes infinity by infinity minus infinity by infinity. So let's just do that. This becomes, I'll now write the limit 3x cubed by root 3x cubed, 3x cubed plus root x minus x by the denominator again. But according to the limit property, this limit actually distributes to the minus. So now let's check each of these cases. Here put infinity, now we get infinity by infinity, and here put infinity, we'll get also infinity by infinity. But the good thing about this is now we can use L'Hospital's rule, with otherwise in here and here we couldn't. So L'Hospital's rule, this becomes 9x square by, take root 3 as constant, put that outside, into the derivative of root x cubed, which we can write as x to the power 3 by 2, power comes down, minus 1, so this is 3 by 2, x to the power 1 by 2, which is root x, so 3 into 3 by 2 root x, plus this is 1 by 2 root x, because root x we can write as x to the power 1 by 2, power comes down, minus 1, so this is 1 by 2 x to the power minus 1 by 2, which the minus comes below and becomes root x. And also right here we have to do the L'Hospital rules again. So here x is simply 1, and this, well, is the same thing, 3 root 3 by 2 root x plus 1 by 2 root x. Now you can actually put the limit over here, because now this becomes 1 by, this part is infinity, and this part 1 by infinity, this is 0. So you'll get 1 by infinity plus 0, simply 1 by infinity, and this whole thing is 0. But what about right here? again we have infinity by infinity plus 0, so infinity by infinity again. So we have to use L'Hospital rule again. So 18x by 3 root 3 by 2 into that we already know root x derivative is that, so 1 by 2 root x plus 1 by 2 into the derivative of, well, now this becomes x to the power minus 1 by 2. So this comes down, becomes minus 1 by 2 minus 1. So x to the power minus 3 by 2, which goes below x to the power 3 by 2, which we can rewrite as whole root of x cube. So minus 1 by 2 root x cube. So let's put the infinity now. If you put infinity over here, this will be infinity by this whole thing. Since we have 1 by root x, this is 1 by infinity, so this is 0. And again we also have 1 by, well, infinity, which is 0. 0 plus 0, which is 0. And now this is infinity. So this is infinity by 0. Now this is a wild case, because here we cannot use L'Hospital's rule. Yeah. And also this is indeterminate, so what we can do now here is, well, we have x right here. This x is the problem, because this causes infinity by 0. So let's just multiply it by 1 by x to remove it. But since we did in the numerator, we also have to multiply the denominator by 1 by x. In that way, this becomes limit the 18 by 3 root 3 by 4, and then the x simply multiplies to the denominator. So this is x root x minus 1 by 4 x root x cube. Now put the limit in. This is 18 by something minus infinity, so this is just 0. This whole thing also 0. 0 minus 0 is 0, and something by 0 is infinity. So yeah, that is the long one to solve this limit. And now let's begin with the third process. So for the third process, now I'll rewrite this. But I'll separate the square roots or the roots. And what I'll do first, I don't want to see this x cube. So let's just multiply it with 1 by x cube, and we have to do it below as well. So this just becomes 3 x by x cube, which is just 1 by x square, by root 3 root x cube by x cube. So this is just the square of that. So we get 1 by root x cube plus root x by x cube. Well, x cube is just root x to the power 6, and that divide that, just 1 by root x to the power 5. Now put the limit in. So this is something by infinity, which is 0. Something by infinity, which is 0. 0 plus 0 is 0. But what about right here? Well, 1 by, well, whatever, this is just 0, right? And we'll get 3 by 0, so this is also infinity. Now, what we can also do is, I also find in the second step, I didn't want to see, or the third process, I didn't want to see x cube. Now I don't want to see root x cube, so I'll just remove that by multiplying with root x cube, and right here as well. So now we get, well, this is just the square of that, so root 3x cube minus x, this is you can rewrite it as x square root, so this is 1 by root x by, this is just root 3 plus, this is just 1 by root x square. Now put the limit in. This part is infinity, this part 1 by this is 0, this is root 3, this is. So let's begin with the fifth process. But actually let's begin with the fifth, sixth and seventh process, because what I'll do right here, from the start of this I rationalize it, and now what I'll do is I'll take x common. So but I want to eliminate this x from numerator as well as denominator. So let's just take x common, and this is root 3 into x, because root x cube is just x into root x, so remaining is root x, plus this is the square of that, so that means this is 1 by root x. Just you can multiply it out and you can see we get that. Again, I don't even think we have to check, this is infinity by infinity, but instead of writing that, let's cancel the x's first, and now let's check if it is infinity by infinity. So this is infinity minus that is infinity whole thing, this is infinity plus 1 by infinity, so 0, infinity by infinity, yeah. Now let's begin with the fifth process. I'll rewrite that 3x square minus 1 by root 3x plus 1 by root x. Now let's see. Okay, so infinity by infinity case, right? Well, we can just use L'Hospital's rule right here. 3x squared, this is a 6x by root 3x, which is just root 3 into root x, and as we did earlier, derivative of root x is just 1 by 2x, so this is 2 root x, plus we did that earlier as well, this is minus 1 by 2 root x cube. Now this is infinity by, this is 0, this is also 0, infinity by 0, a wild case again. So right here, let's multiply by 1 by x. So, and since we did a numerator, we have to do a denominator as well. When we do that, x and x cancels, and this just distributes over the denominator over here. So this is x limit infinity 6 by root 3 by 2, simply x root x, minus 1 by 2 x root x cube. Put the limit in. This is 1 by 0, or sorry, just 0. This is 0, 0 minus 0, 0, 6 by 0, infinity. Now, for the sixth process, what I would like to do here is actually separate these two limits, or just separate the two numerators. So this is x limit infinity 3x squared by root 3x plus 1 by root x, minus the limit as it distributes, as I said earlier, 1 by root 3x plus 1 by root x. Now you can just put the limit in here, because this now becomes infinity plus 0, 1 by infinity, so this whole thing is 0. That means we only have to evaluate that. And in fact, it may be kind of cheating to say that this is the, this is the sixth process, because we simply separated that and just made it 0, and yeah, the same process over again. So in fact, as the fifth process, this is the same. In fact, the denominator is also the same. This also becomes 6x, and you have to do that again. So this is also infinity. Kind of cheating you can say. So you can say I only did 6 processes, or even fifth one, because I'm going to do the next process, and you can see if that counts as a different method or not. So, but I think, yeah, the next process, it should count, because here we have x limit infinity 3x squared minus 1 by root 3x plus, now I don't want to see this x squared, so 1 by x squared into 1 by x squared as well. So this, the x squared gets removed, this just goes below, by root 3 into root x by x squared. Well, x square is just root x to the power 4, x by x to the power 4, so 1 by root x cube plus or 1 by root x to the power 5. Now put the limit in. Seventh process. Now this part is 0, this part is 0, this part is 0. 3 minus 0 by 0 plus 0, 3 by 0, infinity. Now, oops. Now as I was doing this, I realized just now while talking and while doing this, just now, I think I came up with an 8th process. So let me see. But if the 5th and 6th process counts the same, which I think it should, then this is the real 7th process. But I'll just write 8 for now. So we have the limit 3x squared minus 1 by root 3x plus 1 by root x. Now in the 7th process, I didn't want to see x squared, but now I don't want to see this root x over here, so multiply by 1 by root x and over here as well. This becomes 3 by root x, this is root x cube, right, minus 1 by root x. This just root 3 plus this to multiply 1 by x. Put the limit in. This is infinity minus, well, this is 0 in root 3 plus this is 0. So this is infinity. Infinity minus 0 by root 3 plus 0. Infinity by root 3. This is also infinity. So wow, actually 8 processes, but let's say realistically still 7 processes. So yeah, 7/8 different processes for this one limit, which all is evaluated to be infinity. And if you're in a quick time rush to solve this, just do the first process of taking root x common, and yeah, you find the answer right away. And if you learn something new, please like and subscribe. Thank you.